Yeah, so as we were doing quantitative, right? Remember, so far you are now done with that. You know now how much of this I must mix with that to get this, right? So that's a quantitative aspect of chemical change. But now we should talk about like um, the physical aspects, or rather the energy behind or during these reactions, right? So when you talk about energy, that's when now we say, for you to make a bond, first of all, we must understand that to make a bond, we release energy. Okay? When you make a bond, you release energy. Oh, no, no, no. Yeah, yeah. To make a bond, you release energy, right? And then to break a bond, you absorb energy. To break a bond, um, we our particles absorb energy. That's very key. So it takes us back to when you learned about, remember this diagram. Oh, sorry. What's that diagram? This one that was like this, right? I hope that you did it at school, right? When you were discussing how a bond forms, right? So we it gave us a clear understanding of how energy changes during a reaction. Now, right now, we then are going to talk about what we call things like enthalpy and the likes. So, there are two things that usually happen um, when we form a bond. Someone says they can't join. Can I just share the link with them? I don't understand how they can't join. Okay. Yeah, I sent. Okay. So we have two types of reactions. In all reactions that we're gonna have, we have two main types. Okay. So we have exothermic reactions. Um, okay. Now they can join. Oh, nice. So we have two types of reactions: exothermic reactions and endothermic reactions. Endothermic reactions. Can anyone tell us the difference between the two reactions? Anyone can tell us the difference between endothermic and exothermic reactions? Uh-huh. Okay. So the two main difference, yeah, it is the absorption and the release of energy. So when you give the definitions, because we need to know definitions, usually when you define an exothermic reaction, you say it's a chemical reaction, or it's a reaction that release energy. A chemical reaction, a chemical reaction that releases energy. Release energy. And then this one, you're talking about a chemical reaction that absorbs energy. That is what you're talking about there. So exothermic is a chemical reaction that release energy, and then the other one you absorb. So just to also ask, ne, um, which reaction? So because these reactions usually they are happening in a container, ne? Which reaction do you think that when I touch the container will feel cold, and which one will feel hot, between exothermic and endo? Anyone who has an idea? Yeah, let's hear from you, Miss Tando. And endo will feel hot. Okay, okay, and then exo will feel a bit cold, ne? Great, 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 great. Um, right. Is that also what you think, Miss Ori? Are you there, Miss Ori? Or maybe we can hear from Miss Katleho. Which one will feel cold? That the exo will feel cold. Okay. All right. No. Uh, no problem. No problem. In that way, we can understand the following, right? Two things. Um, endo actually it feels cold, whereas exo is gonna be hot. So let me put red here for hot on exo, and then let me put cold for endo. But then someone would ask, but we say endo, we are absorbing energy, isn't it? Endo, you are absorbing energy, and exo, you are releasing. So how come something that is absorbing feels cold? Nah. And how come something that release would feel, wait, oh, no. Okay, sorry. Let me just do this. Um, yeah. So just my network is really a problem. Um, the reason why this feels hot is because it's releasing energy into the atmosphere, whereas this one will feel cold because it's absorbing energy into the bonds inside the compounds. Ne, into the bonds inside the compound or the molecule. So that is why we say endothermic are gonna feel cold, because they are taking energy away from the atmosphere, whereas exothermic are releasing energy into the atmosphere. So usually, because of that, exo would be hot, or rather, the temperature is gonna be high. We talk about temperature, right? We don't really say it's gonna be hot and stuff. So now, let's see how we can, what you call, look at the graphs between exo and endo. I'm gonna sketch a graph here like this, and then you guys will tell me whether which one is for endo and which one is for exo. Let's see. Yo, Madim. Not so beautiful, eh? But yeah. Let me draw another one here. Let's see. And then we go like this. Now for A and B, which one is for endo, which one is for exo? Talk to me. A and B there. Which one is for endo, and then which one is for exo? Yes, Miss Tando. Any idea? Mm-hmm. Talk to me. Mm. B. Mm. All right. So you think maybe this is endo, and then here we got exo, if I'm not mistaken. So exo, endo. Okay. Miss Uri, I really hope you're with us there. Really like to hear your thoughts on that. Um, so which one is it, ma'am? Mm. A is exo, and then B will be endo. Okay. Miss Katleho? A exo, B endo. Okay. No, that is fine. Thank you so much. Thank you so much for that. Now, what we actually look at there, ne, is that you should understand that both of these reactions, ne, endo and exo, they actually absorb and they actually also release. But the question is which one absorbs more and then which one release more energy. You understand? That is what happens there. So in terms of exo, because so yeah, this is exone, this is exothermic, and then this is endo. So in terms of exo, it releases more energy than it absorbs. So this portion tells you the energy that is absorbed. And then this one, it absorbs more energy than it releases. That's why it's called endo. Okay? I hope that that is clear there. That's why we call it endo. So it's gonna release more. Okay? Exo will release more, and then endo will be releasing less but absorbing more. Ne. And then I will show you a way of remembering that. So let's dive deep into this graph and actually label it, because you need to know the labels here, right? So on this exothermic graph, first of all, in terms of the labels, right, we want to say here, from here to there, when you measure from here, this part here is called the activated complex. And then from here to there, we call this our activation energy, EA. Ne? EA stands for activation energy. Activation energy. What is activation energy? Remember that this is the minimum amount of energy required to start a reaction. I hope we remember it. Ne? The minimum amount of energy required to start a reaction. And the activation energy, obviously, it's gonna depend on the type of atoms that want to bond. So it is that energy that is absorbed to form a bond, because remember I told you that for us to form a bond, we absorb energy. Okay, so it is that energy. How much of it do we absorb? Now that is why this portion here is, and then like, okay, let's start with the reactants. So this part is gonna be the reactants. So maybe you might have A reacting with B there, and then here you might have C, which is the product side. Okay, so when you look at the graph, when you interpret it, you must always interpret it in that way. Now another thing we then need to know here, right, is that since this is the activation energy, the reading here is the energy of the reactants. Remember that the y-axis here is gonna read energy perhaps in kilojoules, or they can use joules. It just depends on the question, but those joules is the energy. Okay, so that's what we need to keep in mind. And then obviously this part, let's say from what, the energy of the products would be read here. So when you read the energy of the product, you would read it here, and then the energy of the reactants, you would read them there. So as you can see that which one has more energy between the reactants and the products, guys? Which one has more energy? The reactants. Yeah, that is true. Reactants have more energy. Now here we're gonna have what we call the enthalpy. We have what we call the enthalpy. Now enthalpy is what? It's going to be, it's also called heat of reaction. It's the energy of the product minus energy of the reactants. Okay, energy of the products minus energy of reactants. So you might want to just maybe write down that formula so that we shall be using it in other questions. So when we say energy of the product, we read this value here, then you will know the energy of the product, and then energy of the reactants will be there. So if we were to calculate this, is our enthalpy going to be positive or is our enthalpy going to be negative? What do we think there? Is our enthalpy going to be positive or negative? Energy of the product, consider the energy of the product. Would our enthalpy be positive or negative? Looking at which value would be higher. Negative? Negative? Okay. I hear negative. Is that what we all are in agreement of? Great. So indeed, it's going to be negative there because the products are having less energy as compared to the reactants. So that's what is very much important and what we always need to remember there. Okay. And then let's see. And then another thing again, right, that we need to recall there, we can actually write it like this though, that it's gonna be negative. This is a characteristic of exothermic reactions. The enthalpy would always be negative. So when you get the enthalpy or the heat of reaction on the question, it's gonna be like maybe negative, maybe 1000 kilojoules or joules, you understand, when you calculate it. Depends on the exact values, of course, but then it's gonna be negative. So exothermic, the enthalpy is negative. The same thing, or rather how we actually labeled this, is the exact same way in which you would label this side. So this side also, this part is your activation energy, and then this part is your reactants, whereas this side is your product. But you can see that here it absorbs more, so the activation energy seems to be a bit much higher. And then look at the energy of the product. When you read the energy of the product here, I hope you can tell that the energy of the product is greater as compared to the energy of the reactants. So the enthalpy is the distance between the products and your energy of products and reactants. So it's going to be products minus reactants still, and we are gonna get the enthalpy as less than 0. No, sorry, as positive now, because the products have higher energy. Okay, they have higher energy for endothermic reactions, so therefore you would get that the enthalpy will be positive. And that's how you should just remember it. Okay, so just to recap there: endothermic, exothermic, right? And then know that your endothermic reactions, they absorb more energy than they release, as you can see here. They absorb more energy than they release, whereas our exothermic, right, they absorb less energy and release more. Exo release more, endo release less. Okay, or exo release more, endo absorbs more. Right, and then our activation energy, please remember that activation energy is the energy between the activated complex and reactants. So you can say the activated complex minus the reactants. Okay, so let me write it here. Activation energy is gonna be energy of the activated complex. Activated complex minus energy of the reactant, like that. So that's gonna give you the activation energy. I'm doing this so that when you are reading the graphs there, then it's easy to see, and then you can be able to answer the questions. And then how you can remember all of this, right? Because sometimes these things are a lot and you just need a quick way to remember them. Well, I happen to have a quick way in which you can remember them. But when we were taught, I don't know, I can say the teachers who were teaching us, uh, from public schools, teachers there, no offense, but they can just say anything, to be honest. They don't really care much. So, but not all of them, of course, some. So, us, we had this guy who used to tell us a lot of times these examples would be about dating. You understand? In most of his examples, I don't know if that's because he knew we relate to it, or some of us related to it. Some of us didn't, but we understood what was happening. So, he would tell us that if you want to remember exothermic reaction, think about your ex. Yeah, obviously not. I know you guys, you have never heard of that, but I'm just saying, think about your ex, right? It could be your ex friend. Now, that ex, right? Um, Usually, they became an ex. Why? Because you released them from your life. You understand? They became your ex because you released them from your life. So that reminds you that exo releases more than it absorbs. And then, because you release them from your life, if you go to anyone and then asks maybe that what does your ex say about you? In most cases, our exes don't really say good things, positive things about us. In most cases, they say very negative stuff. You understand? So that is how you can remember exothermic reactions, that we released our ex, and when we ask them, they say some negative stuff in most cases. So therefore, the enthalpy or the heat of reaction must always be negative when you're dealing with exothermic. Then the opposite occurs for endothermic. If you got exo, obviously, then you remember your endothermic reaction. Okay, so how can we see that a reaction is endo or exo given a certain reaction? So I'm just gonna give you an example. Let's say we have hydrogen plus chlorine, and then we're given that it produces hydrogen chloride. So you're gonna have 2 there, you've balanced it. If they say to you change in enthalpy is plus 3,5 maybe kilojoules, would this be an exothermic reaction or endothermic reaction? Real quick, Miss Katlego. Oh, oh, thank you, Miss Ori. Yeah, endothermic, according to Miss Ori's endo, which is true, guys, because the enthalpy, as we can see, is greater than 0, or rather is positive. So positive is endo, negative is exo. Okay, that is fine. That was quite nice and easy. Let me give you another one. Let's see if you can tell whether this is endo or it is exo. Anyone who can tell me, is this an exothermic reaction or an endothermic reaction? Anyone? Um, what about this one, Miss Uri? You'd say exo. Okay. Okay. Um, and then Miss Tando. Exo. Wow. Okay. Okay. Miss Katleho. Endo. Endo. Okay. Okay. So, guys, when you see the enthalpy on the left, ne, or rather that energy there that's being there, if you see it on the left, try to put it on the right, you understand, so that you can read it nicely. But this question and these, they are different, ne? These are not the same questions. How are they different? Here the enthalpy was given to us, but here you are not really given the enthalpy. You are actually given the amount of energy that is being absorbed. You understand? So when you say minus this, you are talking about, you are saying the energy of these guys, you are removing it, or rather it's more of like you you are absorbing, or rather it's more of like the energy of hydrogen and chlorine, right? We are removing some of the energy of those guys. So we are removing energy of the reactants. Ne? And if you are removing energy of the reactants, um, then that means that this is going to be an exothermic reaction. So this is gonna be exothermic reaction. And then the way to see it, guys, it makes much more sense if you were to take this term to the right. And then how you do that, you just simply say the following. You take that, and then you take that, you say it's gonna be 2HCl, and then you say plus 3.5 kilojoules. Okay, so once you take it to the right, it makes sense that we are producing HCl but with an extra release of energy. You understand? And the the moment we say release, because it says plus 3.5, you understand, this is not the enthalpy, but it is the amount of energy that was released. Ne? Because enthalpy is the energy of the products minus energy of the reactants. This one is not enthalpy, but rather it's the actual amount of energy that was released. I hope that we are together. So since it's the energy that was released, which reaction releases energy is our exothermic reaction. You see? Yeah. I hope that is clear, guys. So let's say you have the following. And then they say minus 3.5 kilojoules. So once it's like this, then it becomes endothermic reaction. We're not looking at this, we're not really saying, we're not looking at the sign of this and deciding, because this thing is not enthalpy. Ne? But we are saying that because it is minus, you formed HCl, then you removed some energy from it, then that means the system, the atmosphere is going to have less energy, which tells you that you are dealing with endothermic reaction. So this is just the two ways in which they can ask you whether the reaction is endo or exo. I just need you to look at the position, or rather where the energy is. Okay, the actual energy being released and the actual energy being absorbed. Check whether you are given that. If you're not given actual energy released or absorbed, then you're gonna be given the enthalpy itself. Then if they say to you maybe the enthalpy, they give you the reaction, because they would write it, and sorry for the handwriting, and then let's say you're forming HCl, so that's aqueous, just balance it. So if they give you that the enthalpy here is minus 3.5 kilojoules, they give you the enthalpy itself, then therefore that's when you would say this is exo. Okay, you'd say this is exothermic reaction, because the enthalpy is negative. But if the enthalpy is positive, is endo. Nay, then if they give you the actual energy that was released or the actual energy that was absorbed, then you'll be able to tell them there. I hope that this is clear, guys. Any questions so far? Nice. So that is it. If you know how to interpret the graphs, right, and then you know how to interpret it in terms of reactions, you're okay with this topic. The only thing that you will need to remember is the definitions, and then interpreting the graphs. Also, I think you'll need to know how to calculate some activation energy and the likes. Yes, talk to me, Mr. No. Mm, 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 mm-hmm, mm-hmm, mm-hmm. Okay, no problem. Okay. Let me just do it this way now. So let me say to you, let's just say you are dealing with H. Just gonna make it a simple one. H plus O2 giving us H2O, and then you got a 2 there, you got a 2 there. Now the way in which the reaction will be presented, ne? Let's just say that the enthalpy of this is 3 comma no, let me just use another value. Let me say plus, or I can even just write it as 8.6 kilojoules, taking into note that that's a positive number there. So this reaction, is it an endo or exo, Mr. Ando? It's endo, no problem. It's endothermic. Nice. Now that we know that it's endothermic, another way that we can give you the same reaction, the same endothermic reaction, another way is that we can have 2H2 plus oxygen, and then we're gonna say plus let's just say 100 kilojoules, oh, giving us 2H2O. Now what you should see from this is that the energy is part of the reaction, ne? Whereas here we just gave you the enthalpy of the whole reaction, because we already calculated the difference between the energy of the product minus the energy of the reactants, right? Then we gave you this value, but here you do not have the energy of the products per se, you don't have energy of the reactants, and you don't have the difference between them. but rather you have that energy that is being absorbed or that is being released, right? But then how will you know whether it's this still an endo or exo? So what I was saying, Mr. Anu, is that you should always take that energy that is part of the reaction, take it to the right. When you take it to the right, it means you rearrange. And then if we rearrange it, this is gonna be 2H2 plus O2, giving us 2H2O minus 100 kilojoules. Once you have taken it to the right, that's when you can look at its sign and say, oh, it's saying minus, so minus means to remove, right? If we had a plus here, it would mean to I said remove. No, remove. More like absorb. Sorry. Yeah, think of it more like absorbing, and then plus think of it as a releasing energy. Yeah, releasing energy. So because here we would have a minus, that means that the reaction is real is absorbing energy, right? And because it's absorbing, it becomes endothermic. But if it was like this, plus 100 kilojoules, yeah, then it should mean that this is an exothermic. Yeah, it should mean that it's an exothermic because it's releasing energy. Plus release minus absorb. And then, so I was saying that these type of questions are different from when you are given the enthalpy. So for the enthalpy, if it's plus, it's endo. Whereas if it's minus, it's gonna be exo. So for enthalpy is the opposite of whatever we are saying here. I don't know if it's clear, Mr. Ando. Okay, great. Yeah, so that is how we look at it there. You need to check whether it's gonna be like, is it part of the reaction or not. So yeah, we gonna try and look at a few questions just to see how we can apply that in a test or in exams. Hopefully I can find a certain paper 2019. Yeah, so we're just gonna do this question so that we understand better what is happening there. Copy that and then paste. Right, so here's a nice question here. We have a reaction of carbon with steam. So the graph is not drawn to scale, but it represents the change in potential energy of the substances during the reaction. 7.1, define the term heat of reaction. Heat of reaction is your enthalpy, which is your change in H. So how do we define enthalpy or our heat of reaction? Is there anyone who knows the definition? Okay, no problem. So when you define it, right, you say the energy absorbed or released per mole in a chemical reaction. Remember, definitions is 2 or 0. So you say the energy absorbed or released, per mole in a chemical reaction. Per mole in a chemical reaction. Energy released or absorb per mole in a chemical reaction. So you must not forget the word per mole. If you don't include it, it's not gonna be a complete definition. Is the reaction here endothermic or exothermic? Give a reason for the answer. Is there anyone who wanna try this, guys? Can you tell me, anyone? Is it endo or exo? Endo, exo. Endo. Okay. Anyone else? Endo. Ah, great, great. Yes, that is true. It is an endothermic reaction. But how would you support that? Because they say give a reason for your answer. So how would we support that this is an endothermic reaction? That's correct, Tanda. The products, the energy of the products is higher than the energy of the reactants. Ooh, you see, I'm very lazy. Just use inequality there. But they will know you're maths people, by the way, and you're taught by me. So just do that. Okay, is there any other reason we can give here to support that this is an endothermic reaction? One, two, one, two. Anyone? One, two, one, two. Yes, yes, don't worry. You can tell me, Miss Katlego. I see that you are raising your hand. Is there any other reason we can give to say that it's endo? Very correct. So you can say more energy was absorbed than released. Wow, guys, this is brilliant. Very much correct. And then lastly, you can also simply just say the enthalpy is greater than 0. Okay, now you are learning it. 7.3.1, use the information on the graph and write down the value of the activation energy. Very nice. What would be our activation energy? Let's see if you can get it. What would be our activation energy? So activation energy, remember, it's this part from the reactants to the activated complex. Okay, so you simply say the top part, the highest part, minus the energy of the reactants. So that means you would say 593 minus 49. So 593 minus 49, 544. 544. And then what are the units here? Write the units as they are: kilojoules per mole. Kilojoules per mole. And then for the heat of reaction, which is the enthalpy, remember that it is this part, right? That's your enthalpy between the products and the reactants. So it will be the energy of the products, which is 180, minus the energy of the reactants, which is gonna give you how much. Obviously you would need to write this, guys. So 180 minus 49, so you get 131. 131 kilojoules per mole. Perfect. I hope that you can see how we can tackle these questions, guys. So essentially that is just what you need to know and more. So keep studying this, and then You see, this is a section in chemistry you must always get total. You would rather lose marks somewhere, but you can't lose marks here because it's very short and sweet. Now, is there any question, guys, we have from that? Anyway, we didn't understand? And if you understood, you can give me a thumbs up so that I know. If you didn't, you can give me a thumbs down so that I know. Okay, we'll start with Miss Uri then. Miss Uri, I saw you putting that face, that says, what? What? I, I sure it was a mistake, ma'am. Oh, I see, I see. No problem, no problem. Yes, Mr. Kevin, you came in a bit late, sir, but talk to me. The heat of reaction, we said remember, heat of reaction is the energy of the products minus the energy of the reactants. So the energy of the products would be that, and then the energy of the reactants would be that. So we say 180 minus 49. Energy of products. Yes, yes, yes. Is that okay? Okay, but make sure to go back to the recording of the whole session to get a nice basic understanding of this. But otherwise, guys, that is it. Yeah, keep practicing. If you find any questions, quite interesting questions, you can just send to me and then we'll look at it. Otherwise, see you on Wednesday. Have yourself a great week ahead.